We are taking a look at section 1.8 today, translating words into math. And this is sometimes a difficult thing to do, but very useful for those of you who struggle with solving word problems. This section is going to help you look for keywords that will allow you to set up algebraic expressions and equations in the future. So we're going to go through this. Just a reminder, make sure you have your note packet in front of you. In a minute, I'm going to ask you to pause the video and fill in this initial table here, because there is quite a bit of writing for you to do. But again, pencil in front of you and your note packet. And by the time we're done with this video, you should feel more comfortable being able to find keywords, specifically in story problems, to help you figure out what operations you'll be performing and pulling out key information also to find the constants and the variables that you'll be needed, that you will need to solve your problem. So let's take a look at this table. We're looking at 4 different operations here: adding, subtracting, multiplying, and dividing. And the first one here, add. Definition for adding is putting something together or combining, which you should feel pretty comfortable with knowing. An example here, we have r plus 5, so we use our addition sign. Some of the key words that you should be looking for when you are solving your problems would be plus. You see the actual word add. The word sum is the answer to an addition problem. Also, when you see the words more than, would indicate that you should be adding. So again, these are just a few keywords that when you are solving story problems to look for, and that way you would know that you would be adding some terms together. The second one here, and actually go ahead and pause the video right now and make sure you get these filled in if you haven't done so already. Okay, we're back. Panthers, let's take a look at subtracting. Subtracting is finding the difference between two terms, and of course we know that we use a subtraction sign. Some keywords that you might look for in a word problem is the actual word to subtract. Perhaps you'll see the word minus, difference, take away, and less than. When you see these terms, you would typically perform a subtraction operation. Again, if you have not filled in these terms, go ahead and pause the video and get them filled in. And for multiply, multiplying means to combine equal groups. Combine equal groups. If you're ever reading a story problem and you're adding the same thing over and over and over again, you have repetitive addition, the shortcut for that, if you remember, is to multiply. So again, you're combining or adding together equal groups. The shortcut would be to multiply. Now, last year you learned a little bit about some different ways to write multiplication. Typically, what you probably remember is using the X symbol for the multiplication sign. And we've talked a little bit this year about how we want to kind of get away from using the X anymore. We're now 7th graders. We're moving into the land of algebra, and X is no longer going to be an acceptable way to write a multiplication symbol. And if you remember what we talked about, now that we are using variables, and we tend to see X used a lot as a variable, we wouldn't want to have something that looks like this, 7 times X, because that looks very silly. You don't need to write that down in your notes. But just so you know, I'm going to kind of cross this off in our notes. I would prefer you from this point forward not to be writing that yourself. However, you'll still see it written in your textbook and some of your practice sheets, so I want you to be familiar with it. But some acceptable uses for multiplication or ways to write multiplication. The first one here, again, we've talked a little bit about this. When you have a number and a variable back to back, that indicates a multiplication term. This is 7 times t. So when you have a number and a variable back to back, that means to multiply. We also have talked about using that little dot. Okay, the dot replaces the X so we don't get confused. And we also talked a little bit with the distributive property that when you have a number outside attached to something inside the parentheses, also indicates multiplication. Okay. Let's take a look at dividing. Dividing isn't combining into equal groups, you are separating again into equal groups. You're taking them out and you're separating them equally. And here again, a couple things we've talked about in class. We have a fraction bar. Remember, a fraction bar is the same thing as a division sign, so this would indicate m divided by 2. We have a slash, okay, again, just like a fraction bar, this also means m divided by 2, and then we have our trusty old division sign, which we can use. So again, you need to be familiar with all of these different formats for adding, subtracting, multiplying, dividing. I would encourage you to use them in your own work, kind of vary up the ways that you are actually writing these as well. And in a story problem, when you see the words divided by, obviously that probably means you're going to be dividing. You also might see the word quotient. Quotient, again, is the answer to a division problem. And then down here at the bottom, again, go ahead and pause me and fill out this information about parentheses. Okay, welcome back. The parentheses, or another way to, when you see parentheses, what you should be saying is the quantity of. The sum of, the difference of, the product of, and the quotient of. These are all different ways. So for example, if I had this expression, the way I would read this is 2 plus the quantity of 3x, okay? 2 plus the quantity of 3x. So whenever you're about to say something in parentheses, prior to reading the inside of your parentheses, you are going to say the quantity of 3x. Or the product, in this case, since you're multiplying inside, you could say the product of 3x. Okay, Panthers, let's practice. We're taking a look at some example problems here. We have to write each phrase as an algebraic expression. So again, what I want to do is translate the words into operations, into numbers, and into variables. So I'm going to break it down. Here we go. Letter A. The quotient of a number and 4. I'm going to go through and nitpick all the key pieces here. First of all, I see the word quotient, which means to, do you remember? Divide. The quotient of a number, a number. Now, do we know this number? No. Since we don't know this number, we're going to choose a variable. Now, ladies and gentlemen, when you're choosing your variables, please get in the habit of using the letter that what you're talking about begins with. So we don't know what this number is. I'm going to use n as my variable. Again, this is the unknown. So I'm going to choose the first letter of what it represents. So we're finding the quotient of a number and 4. That's our constant. That's what we know. So obviously we have the n and 4 here, and we're going to be dividing them. Now in this case, we're taking the quotient of n and a number. So this would be n divided by 4. It could also be written like a fraction, n divided by 4, or n divided by 4, all of which are acceptable answers. Okay. Letter B. We have w. This would be our variable. Increased by. Do you remember what increased by would suggest? This would be an addition problem. And then we have 5. W is increased by 5. So we have W, and then it was increased. A couple things I want you when you read these. Increased by suggests kind of a past tense. So W was there first, and then it was increased by 5. So we're going to add 5 to W. Okay. And letter C, the difference. Difference means to subtract. We have 3 times a number. 3 times a number. So again, there's that word number again. I don't know what number we're talking about. So that's our variable. And I'm going to write 3 times a number. I'm going to write just 3n, remembering, Panthers, that when you have a number and a variable back to back, it indicates that we are multiplying. So 3 times a number, 3 times n, and 7. Now, and is kind of a crucial separation here, okay? We're finding the difference of 3 times a number and 7. Typically, when you see that word and, it allows you to think that this subtraction sign should be inserted in that position, okay? So this is going to be 3 times a number, and then we're finding the difference between that and 7. And we get this answer here. 3 times n minus 7. Okay, so again, look for those ands. They usually indicate kind of a separation so you know where to place your operation. And letter D, the quotient, okay, this is division, of 4, oh, there's an and, this is a separator, a number, which we don't know, and then we also have something going on here. We're also increased or adding 10. So let's take a look. The quotient means we're going to be dividing. So again, the separator kind of tells us what we're dividing. We're dividing 4 and a number. So this would be like 4 divided by n. And then that is increased by 10. And again, pay attention. Increase suggests a past tense or occurring after something. So here we're dividing 4 by n, and then we are adding 10. Okay, so let's take a look at a couple story problems here. A, Mr. Campbell drives at 55 miles per hour. Write an expression for how far he can drive in h hours. So again, think about our problem-solving strategies that we've talked about. Sit back and try to make sense of this problem, and let's take a look. Mr. Campbell drives at 55 miles per hour. Write an expression for how far he can drive. I'm going to set up a little table here. I know that if Mr. Campbell drives 1 hour, I would multiply 1 times 55. If he drove for 2 hours, it'd be 2 times 55. So essentially what we're doing is we're taking the speed and we're multiplying it by the number of hours. Now, I don't know what hours is, so I'm going to use a variable of h. We do know his speed, which is a constant of 55, and I'm going to multiply that by h, and that gives us an expression that represents the situation. And letter B, on a history test, Maritza scored 50 points on the essay. Okay, that's a one-time thing. That's her total, 50 points. Besides the essay, each short answer question, each is a key word, was worth 2 points. Okay? Write an expression for her total points if she answered Q short questions correctly. So we know her total was 50 points. Okay? We know that each question, or Q, is worth 2. So if she answered 1, it'd be 2 times 1. If she answered 2 questions, it'd be 2 times 2, which is 4. So each question is worth 2 points. In other words, each question multiplied by 2 will give you her score. But she also answered an essay, which was worth 50 points. So each question gets multiplied by 2 for 2 points, plus a total of 50 points for the essay. We come up with an algebraic expression. Okay, Panthers, here's a joke for you to end. What occurs once in every minute, twice in every moment, and yet never in a